Hey, good evening, Professor, or whenever you're watching this. Thank you for giving me another chance. The wording on the project one was kind of weird. It implied like one question is good, but it was kind of weird. All right. Anyways, but now I know not to do that again. Anyways, we are going to start with problem A. As we can see right here, if you follow my cursor, this is straight from the Project One handbook. This is limit h pointing to zero, square root of 15h plus 4 minus 2 over h. And that's our answer right there, 15 over 4. Easy, right? No, not really. Now we gotta show the work of how we do it. These screenshots I found an online way to type out every freaking thing. Thank God, because to type it all out the equation, it hurts my hands. Anyways, first we gotta rationalize the numerator. First, we got to multiply the numerator and the denominator by the conjunctor of the numerator to get rid of the square root in the numerator. Yeah, say that 5 times. So we basically are just gonna like multiply that by that, and we cancel out these two right here. And we are going to basically go on to step two, which is to simplify the expression. Now, this is a lot easier to read. Limit h over 0, parentheses 15h plus 4, and parentheses minus 4 over parentheses square root of 15h plus 4 plus 2 parentheses. So if we could simplify it, what it should be is kind of the same, except the top numerator would just be 15h, which goes on to our next step, which is to cancel the common factor. As we could obviously tell, common factor is going to be with square root 15 plus h plus 2. And we get the 15 and the 15, 15 and the 15. We are going to go to step 4, which is to evaluate the limit. It's pretty simple math. Lit is limit h going to 0. It's 15 over square root of 4 plus 2, which equals to 15, 2 plus 2, which equals to 15 over 4. And that's how we got our answer right here. Now, let's go to problem C, the other question I forgot to do. Now, first, it's going to be a little tricky. It's not a lot of math here. It's a lot of symbols more than math, but that's nothing we can do. First, we got to recognize the fundamental trigonomic limit. One of the key trigonomic limits is limit x over 0, sin parentheses x over x should equal to 1. This means as x approaches 0, sin x over x approaches 1. We'll use this property to simplify our limit. Now, step 2 is to manipulate the expression. Notice that expression inside the sine function is 19y rather than just y. To make it easier to apply the fundamental limit, let's rewrite the limit the way it resembles the standard form. And as you can see, we got our little question right here. And then we go to this, 19 times sin 19y and 19 times 4y over, yeah. And then we just kind of like multiply those two out. And then we got to multiply by 1 over 4. Here we multiply and divide by 19 to isolate the expression sin 19 over 19, which now resembles the standard trigonomic form. Might not see it here, but it's right here into step 3, which is to apply the fundamental trigonomic limit. Now let's separate the limits into two parts. It'd be like this, basically. Same, but different, but still same. It's lim y dash 0, parentheses, sin 19y over 19 times lim y to 0, 19 divided by 4. Now, as y approaches 0, the first part of lim y sin 19 over 19 equals 1 by the fundamental trigonomic limit. The second part is just basically multiplication. It's not that tricky. So it's 1 times 19 over 4 And what do you know? We got the answer right here. 19/4. Now, thank you, Professor, for giving me this other chance to explain and show my work. I feel like I show my work better with this compared to typing everything out. It was hard to figure it out, but there's I feel like the idiot for not figuring out there's a lot of like, you know, canvas stuff there. Well, thank you for giving me this chance though, and I hope to see those 6 points back.